Good morning students. I welcome you all to my online class on dynamics. Today we are going to learn a new topic, components of velocity and acceleration along tangential and normal direction. So first of all we'll deduce the expression for components of velocity and acceleration along tangential and normal direction. So just to look at the figure, let a particle be moving along a plane curve C. Let OX and OY be two perpendicular axes on the plane of the motion. Let I cap and J cap be the unit vectors along x-axis and y-axis respectively. Let P be the position of the particle on the curve C at time t with position vector R referred to O as origin. And let T cap and n cap be the unit vectors along the tangent and normal to the curve at P, and let psi be the inclination of the tangent at P with the positive direction of x-axis, and pi by 2 plus psi be the inclination of the tangent of the normal at P with the positive direction of x-axis. Now this unit vector t cap we can write in the components form as a1 I cap plus a2 j cap. So let's take the dot product of this t cap with I cap. So if you take the dot product, you will get with I cap you will get magnitude of t cap, magnitude of I cap, cos of psi. Psi is the angle between t cap and I cap. So from this you will get a1 is equal to what? Cos of psi. In the similar manner, if you take the dot product of t cap with j cap, you will get a2. So from this, the expression for a2, you will get sine of psi. So after getting the components a1 and a2, we can write down the expression for t cap. So what is the expression for t cap? T cap is equal to what? It is I cap cos of psi plus j cap sine of psi. In the similar manner, we can write down the expression for n cap, and you know that n cap makes an angle pi by 2 plus psi in the positive direction of x-axis. So the expression for n cap we can write I cap cos pi by 2 plus psi plus j cap sine pi by 2 plus psi. So from this you will get n cap is equal to what? Minus I cap sine psi plus j cap cos of psi. Okay, now let's differentiate I cap with respect to t. So from this you will get t cap dot. So right hand side if we differentiate with respect to t, you will get minus I cap sine of psi, then psi dot. Psi dot means it is d psi by dt, plus j cap cos of psi, psi dot. So after simplifying this one, we can take common psi dot. So you will get the expression for t cap dot, you will get psi dot n cap. Again, we differentiate this n cap with respect to t. So if you differentiate n cap with respect to t, you will get minus psi dot t cap. Okay, now let v be the velocity of the particle at P on the curve C. Then the expression for velocity v bar, we can write it is dr bar by dt. So by the chain rule of differentiation, we can write it is dr bar by ds and ds by dt. This ds by dt will give you the velocity along the tangent to the curve. So this we can write as v. And dr bar by ds, it is the unit tangent vector along the tangent at P. So we can write t cap v. So here the other terms we can express this way, it is n cap 0. That means here the normal components of velocity is 0. So v bar we can write t cap v plus n cap 0. So coefficient of t cap will give you the tangential velocity, and the coefficient of n cap will give you the normal velocity. So tangential velocity we denote by vt. So the expression for vt is v, and the normal velocity is denoted by v of n, and the expression for normal velocity is 0. Let's deduce the expression for acceleration. So acceleration we can denote by f bar. So let f bar be the acceleration of the particle at P, and acceleration, you know, it is the rate of change of velocity So we can write it is d v bar by dt. So v bar expression already we have obtained. So it is v t cap because normal velocity is 0. So now if you differentiate this one with respect to t by applying product rule of differentiation, you will get v dot t cap plus v t cap dot. So what is the expression for t cap dot? It is psi cap psi dot n cap. This already we have deduced. So now if you this psi cap dot means is what? It is d psi by dt. So by chain rule of differentiation we can write d psi by ds and ds by dt. So this ds by dt will give you the velocity, and d psi by ds it is the radius of curvature. So already we have done in calculus radius of curvature. They are already obtained that radius of curvature is denoted by what? 1 by rho. So what is the expression for d psi by ds? We can write it is 1 by rho. So if you simplify this one, you will get f bar is equal to what? It is v dot t cap plus v square by rho n cap. So the coefficient of t cap in this case will give you the tangential acceleration, and the coefficient of n cap will give you the normal acceleration. So tangential acceleration we can denote it by f of t, and it is given by v dot, or we can write dv by dt. If you simplify further by the chain rule of differentiation, this dv by dt we can write this way: dv by ds, ds by dt. So we can write v dv by ds. And normal acceleration we can write as f of this should be n. So f of n is equal to a normal acceleration. It is v square by rho, or v psi cap dot. Okay, one thing you have to remember, t cap is what? It is the unit tangent vector. This we have expressed as what? d r bar by ds. So this one further we can simplify. So we can write d r bar by dt, then ds by dt. So from this dr by dt we can write v bar, and this we can write as the components of velocity. So if you simplify, see what is the expression for v bar? It is v t cap. V is the magnitude and t cap is the direction. So this way you will obtain the expression for components of velocity and acceleration along the tangential and normal direction. So in next class we'll solve the problem based on this topic. Thank you.